Welcome back to another video. I'm Dr. Tarcia Hubert, and in this video we're going to be talking about combinations. Okay, so what is a combination? We're going to get at that in a little bit, but if you watched the previous video, it was about permutations. So permutations, you use those when you want to figure out how many ways you can arrange a group of things. So if you have a large group and you want to pull like a smaller set from that large group and you want to rearrange it, in such a way where the order actually matters. Okay, so we looked at some examples such as how many ways can a police officer create a 5-person or a 3-person lineup out of 5 suspects. Okay, so that was an example that we looked at. If you missed that video, I'm going to put the link in the description so you can watch it. Now I'm bringing that up because combination is similar to permutation. The only difference here is that now order does not matter. So now when we talked about a lineup of 3 out of 5 suspects, the order mattered because whoever we put in 1, whoever we put in 2, and whoever we put in position 3 is different if we switch it around, if it's a lineup. Okay, so in that case, order matter. But if I just wanted to select how many groups of 3 I could form, how many different ways could I choose 3 of those 5 suspects, now order doesn't matter, and that would be considered a combination. Okay, so here's another example. If a 4-person committee needed to be selected from an organization that had 11 members, how many different committees are possible, right? So in this case, we're not selecting those 4 people to positions. We did an example like that in the permutations video where we were selecting a certain number of people, 3 people from a larger group of people, but we were putting them in specific positions: CEO, operating manager, and treasurer. Well, if we're just forming a committee and we're not putting them in a specific position, then the order does not matter. And in this case, that would be a combination. All right. So the formal definition for combination, we say a combination of items occurs when 1, the items are selected from the same group. So you have only one group that you're selecting from. No item is used more than once. So if I was selecting a group of 4, everybody in the group would be different, and then the order of the items makes no difference. So it doesn't matter who I pick first, who I pick second, who I pick third, who I pick fourth. Alrighty, so if you have those 3 things, then you have a combination. And then the formula for combination looks like this. So it's n factorial all over n minus r factorial, which that was the formula for permutation, right? But then we add r factorial in the denominator, and that makes the formula for combination. So it's really similar to permutation, except we have an extra thing in the denominator, which is the r factorial. So what this means is that this is the number of combinations of n things taking r at a time. So n is how many is in the big group, and r is how many we're selecting from that big group. So let's look at some examples. So for this first example, we just want to look at the situation and decide whether it's a combination or a permutation. So here's the first example, part A. So example 1 has 2 parts. Part A, so suppose 50 people purchase raffle tickets. 3 winning tickets are selected at random. If first prize is $1,000, second prize is $500, and third prize is $100, and how many different ways can the prizes be awarded? Okay, so 50 people bought tickets. That's our total number overall. We're going to select 3 to win, and so now the order actually matters because the first person selected, it could either be the third place or the first place, depending on how you pull them. But the first person's pull is either going to be your third place winner or your first place winner. Then the second person pull will be your second place winner, and then the third person pull will either be your third or first place winner. It just depends. If you want to, most people go third, second, first when they pull, right? So, but the thing is, the order matters. Okay, if the order matters, what do you think it is? Hopefully you said permutation. If you said permutation, ding, 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 you are correct. Okay, here's the second situation. Suppose, so a similar situation, 50 people purchase raffle tickets. 3 winning tickets are selected at random. If each prize is $500, and how many different ways can the prizes be awarded? So now this time, the order does not matter because every person that's pulled will get the same amount of money. So it doesn't matter if I pull your name first, second, or third, you're still going to get the $500. So in this case, what would it be? Combination or permutation? If you said combination, ding, 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 you're right, because the order does not matter, okay? So when you read these situations, you want to look to see if the order matters or if the order does not matter. For the second example, we want to find 12C5. This is a combination of 12 items being selected 5 at a time. And so we can use the formula, which says 12C5 is equal to 12 factorial all over 12 minus 5 factorial all times 5 factorial. So that's equal to 12 factorial over 7 factorial times 5 factorial. So now you can plug it in the calculator like that, or you can work it out piece by piece. I'm grabbing my calculator. Also, if you have a graphing calculator, I don't know if you do or not, but if you do, there's actually a combination button on your calculator. So if you go to your main screen, you will first select the 12. You will type in the 12. Then you will go to math, which is here. You would scroll all the way over to, it says PRB at the top, which stands for probability, and hit enter. And I do that every time. So scroll to PRB and then number 3. So number 2 is the permutation one, you can see, and number 3 is the combination one. So I'll hit number 3. And so I put the 12 first and then the combination. And so then you will put the R, which is the 5, you'll put that second, and it'll give you your answer. So 12, you put the combination symbol, and then 5, and it gives me 792. Now, if you don't have that button, you could just plug in. Remember, I showed you in the previous video how to use the factorial symbol. There is a factorial symbol on your calculator, and there's one on your phone calculator as well. But you can also write this out. You can also write this out and say this is 12 factorial, or 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 7 factorial. And I stopped at 7 factorial because there's a 7 factorial in the bottom, and those 7 factorials will cancel. And then that leaves me with 12 times 11 times 10 times 9 times 8 all over 5 factorial, which is 5 times 4 times 3 times 2 times 1. And you can start dividing stuff out. Like 12 divided by 4 is 3, so I'll cancel out the 12 and 4, and that makes 3. 10 divided by 5 is 2. 9 divided by 3 is 3. 8 divided by 2 is 4. That gets rid of everything in the denominator, and that leaves me with, in the top, 3 times 11 times 2 times 3 times 4. And if you multiply that out, 3 times 11 times 2 times 3 times 4, you get 792. Y'all have to excuse my child in the background. He is having a good time. So you get 792. So there are 792 different ways. Can y'all see my 792? Yeah, you can barely see it, but you can see it. 792 different ways that you can figure out whatever that situation is. But that's just using the formula to figure it out. For example 3, a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the board of supervisors? Okay, so you have 8 people and you're trying to form committees of 3. And since they're not being assigned to specific positions, the order doesn't matter. We just need to choose 3 people out of the 8. So if we want to figure out how many ways that can be done, we'll do 8, choose 3. Again, you can plug that in your calculator. Depending on what kind of calculator you have, will depend on how far you need to go to break it down. So that will be 8 factorial all over 8 minus 3 factorial times 3 factorial. So 8 factorial all over 5 factorial times 3 factorial. So that's 8 times 7 times 6 times 5 factorial. And I stopped at 5 because I see the 5 factorial in the bottom, and those will cancel. And so now I want to break down the 3 factorial, which is 3 times 2 times 1. 6 divided by 3 is 2. 8 divided by 2 is 4. That leaves me with 4. times 7 times 2. 4 times 7 is 28. 28 times 2 is 56. So there are 56 different ways that we could choose a committee of 3 from a number of 8 members on the board of supervisors. All right. All right. And for this last example, example 4, to win the lottery in the state of New York, one must correctly select 6 numbers from 59 numbers. The order in which the selection made does not matter. Okay. You just got to pick the right 6 numbers. How many different selections are possible? Alrighty. So the order doesn't matter, so that lets you know right there it's a combination. So you're going to use the C, and it's 59 numbers total that you use, and you got to get 6 of them right. Okay, and so that would be 59 factorial all over 59 minus 6 factorial all times 6 factorial. So that's 59 factorial times 53 factorial all times 6 factorial. Now, I definitely don't want to break that one down into 59 times 58 times 57 times 56 and so forth. So I'm definitely going to use a calculator for this one. So now everybody do have the factorial button. You should have the factorial button. So I will definitely see what is 59 factorial. Let's see, it might give us something too big to put. Let's see what we get when we put that in. Yeah, so you end up getting something that looks like this with an E in it. Y'all see that? E, that means times 10 to the 80th power. That E, 80 means times 10 to the 80th power. So that's a huge number. That means you will move your decimal 80 places. Okay, so I'm going to do 59 factorial. I'm going to keep it in, and then I'm going to divide it. And then in parentheses, I'm going to put 53 factorial times 6 factorial. So let me show y'all what that looked like. So you have to put the 53 factorial and 6 factorial in parentheses. So when you divide it, so this is how I entered it. I did my answer, which was the 1.386 times 10 to the 80th, divided by parentheses 53 factorial 6 factorial. And now I'm going to hit enter. And this is what I get, this large number right here. So I'm going to write this down. This is 45,057,474. So that is the number of different ways that you can actually select 6 numbers out of 59 numbers. And so this is why it's really hard to win the lottery, because your chances are really, really, really small, because there are so many different ways you can choose 6 numbers out of 59 numbers. Okay, so again, this one I specifically had to put in the calculator. I couldn't just work it out by breaking it down. That's because the numbers are so large. So you will have to use the calculator to figure out what that is. Alrighty. If you have any questions about calculator usage or anything about the combination, please don't hesitate to write your question in the comments or to send me a personal email. Okay. I hope this video helped you. If it did, please hit that like button for me, that thumbs up button. And by now you should have already subscribed to the channel, but if you haven't, go ahead and hit that subscribe button. Thank you so much for watching, and I will see you all in the next video.